In this video, we'll be comparing decimals. We'll use three strategies: relating to fractions, using number lines, and aligning by place value. Let's look at an example. We're going to compare the decimals 2 and 56 hundredths to 2 and 531 thousandths. So first let's look at how a student might make a mistake with this. If they were working with whole numbers recently, like 256 and 2,531, they might have gotten the idea that the more digits we have, the larger the number. And for whole numbers, that rule of thumb will work, but it's not going to work with decimals. So let's first do this one by comparing them, by rewriting them as fractions. We can write 2 and 56 hundredths as a fraction by ignoring the decimal and then noting that tenths, hundredths, we're talking about hundredths, so we'll put this over 100. And for this one, ignoring the decimal, so 2,531. And here we have tenths, hundredths, thousandths, so we'll put 1,000 in the denominator. Now, if you've worked with fractions before, it looks like this would be a really great one to use a common denominator with. So we can write this with the common denominator of 1,000. This becomes 2,560 thousandths versus 2,531 thousandths. And all we have to do, since we've partitioned the whole into the same size parts, thousandths, is compare the number of parts, that's the numerator. Since the numerator on the left is larger, then that'll make the fraction on the left larger. So we can insert a greater than symbol. So in this case, even though there were more digits in this number, 2 and 56 hundredths ended up being the larger number. Next, let's use a number line to compare. So recall with number lines that numbers to the right are greater and numbers to the left are less. Because we're working with decimal numbers, we'll use a base 10 number line. Let's think about what we want our major ticks to be. Well, we're going to look and see what these numbers have in common. They both start with a 2. They have that in common. They both have 5 tenths. They have that in common. And then they differ when we get to the thousandths. So let's start our number line on the left with what they have in common. A base 10 number line has 10 spaces between major ticks. And here, I have 2 and 5 tenths, so I'll be counting by tenths. My major tick is in tenths. So 2 and 5 tenths, the next tenth that I have is 2 and 6 tenths. Then I can fill in with my minors. My minors will be one place value over, so we'll have hundredths here. 2 and 51 hundredths, 2 and 52 hundredths, and so on. Now we can plot our numbers. There's a spot for 2 and 56 hundredths. And then for our other number, well, we have the 2, we have the 5, we have 2 and 53 hundredths, and then we have another thousandth. So that'll be just to the right. We'll have 2 and 531 thousandths. So the number to the right is 2 and 56 hundredths, so it'll be the larger number. As a side note, if the two numbers that you're comparing didn't have anything in common, so if we were, for example, comparing 2 and 56 hundredths to 531 thousandths, so we'll change that ones place there, then what do they have in common? We're working from the left. They don't have anything in common, so we'll go to the tens place and see that they both have a 0 in the tens place, and then we could create our base 10 number line, thinking that we'll start with 0 tens, and then we'll be counting by tens, which means that our minor ticks will be ones. And we can plot our points. We'll come to 2, and then a little bit past the halfway will be 2 and 56 hundredths. And then for the other number, we're just past, we start at 0, and then we're just past the halfway point between 0 and 1. So we'd be able to see that 2 and 56 hundredths would be further to the right, so it would be greater. So it's okay to introduce a new place in order to get a common starting place and then build your number line. All right, back to our original numbers. Now let's use aligning the place values, and we'll justify that with our base 10 blocks. The strategy here is to put the ones in the same column, so we'll align by place value, or you can think of aligning the decimal point here. So we'll have 2 and 56 hundredths versus 2 and 531 thousandths. Some people like to add a 0 in, so there's a digit in every column, and we start from the left and start comparing. These are the same, these are the same. Now we have a difference, so we'll go with the larger number. 6 is larger than 3, which will make 2 and 56 hundredths larger than 2 and 531 thousandths. Why does this work? Anytime that we're memorizing a procedure, it's good to think about why it works. If we were to build these with standard base 10 manipulatives, we'd be looking to see which number took up the most space. Well, they'd both take up equal amount of space with the ones, and they'd both take up equal amount of space with the tenths, but they'd take up more space 6 hundredths versus 3 hundredths. As we're building our base 10 model, we choose our key such that the smallest manipulative, the little unit, is equal to the smallest place value. So our smallest place value is going to be the thousandths. The rod will be the hundredths, the flat will be the tenths, and the 3D cube will be the ones place. Let's go build this. Okay, so we had 2 and 56 hundredths, 2 ones, 2.5, so 5 in the tenths place. So we'll put 5 flats in here. And then we had 6 hundredths, 2.56. So we'll put 6 rods right here. Our next number, we still had 2 ones, 2.5, so 5 tenths. We can see that our first 2 columns here are the same, but then we had 3 hundredths. We can see that the top number is taking up more space. We'll finish this up by putting 1,000th in there, but even if I had had 9 thousandths, 9 of those little units can't overtake 1 rod because the rod contains 10. So by building the model, we can see that the top number takes up more space, even though it has fewer digits, and so it's going to be the larger number. Let's look at some elementary workbook pages and see how these ideas show up there. Here, we can see that students are encouraged to build the numbers with base 10 blocks and compare them. On the next page here, we're aligning the like place values, and it looks like maybe we're coloring in. So we'll also look at base 10 grid paper to compare our 2 numbers. So we could be looking, rather than the blocks, we could be looking at a shaded in grid. We also can see that we're looking at a number line, so plotting the numbers can help us determine which one is the larger number. Let's represent this problem with base 10 grid paper. We have a bit of a dilemma because in terms of manipulatives, this corresponds to the unit, the rod, and the flat. There isn't really a 3D version of this. We'd have to shade in 10 of those blocks, which is a lot of coloring. So what we're going to do is we're going to make the smallest place value just a fraction of one of the squares. So then we can have the hundredths place represent one of those little boxes. So if we go back to our notation of 1 unit is going to be 100th, then 1 rod or 1 set of 10 will be a 10th, and then one of these squares will be 1. So as I represent 2 and 56 hundredths, I'm going to need to shade in 2 of the large squares, 2 sets of 100. If each small square is a hundredth, then having 100 of them will add up to 1. Then we'll have 5 tenths, that's a 10 by 1. And then finally we'll finish up with 6 hundredths, that's our little square. 1, 2, 3, 4, 6. So our second number, 2 and 531 thousandths, let's give it a new color. But we'll still have 2 of these large blocks. We'll have 5 of the 10 by 1 columns. But then we'll only have 3 of the hundredths. 1,000th, which will just be a fraction of this right here. So we can see when we compare the area here, especially when we're looking, we're the same for the ones, the same for the tenths, but we've shaded in more on the pink number.